Happy Monday.
Happy Monday, Joe. How's it going?
Good, good. So this week we are going to take a bit of a departure and talk about um, maybe some recent developments with AI and IBM and all that fun stuff. So
Absolutely. And I think we both kind of agree that the struggles that IBM has had are representative of broader struggles in the whole industry, struggles around marketing, buzzwords, and actual delivery of value for companies and the healthcare industry in this case.
yeah, yeah. I don't think our intention is to pick on IBM specifically.
No.
This is definitely not the not the intention here. But this article had popped up um, in my Wall Street Journal feed yesterday. So Um, and it's interesting. So, basically the gist of it is IBM selling off Watson Health, right? So that was pretty big.
Yeah.
It was a pretty big deal. So
Yeah. Since that's been the core of their brand for what would you say, maybe 5 or 6 years ago, Watson itself was like the way forward for IBM, that and IBM Cloud.
yeah, I mean, I remember Watson
Yeah.
was definitely the bee's knees when it come out in 2010. It obviously had the famous win on Jeopardy, and I'll just here's me and my sister actually
Back in the
playing
day.
Watson. Yeah, so we got to check it out, and this was at the Berkshire Hathaway meeting back in 2015, I think. So at the time, Berkshire had invested in IBM as well, and was I think pretty stoked on Watson, as was everybody. But a lot's happened since then too. So
Yeah, absolutely. I suppose we should talk at some point about the notion of general purpose AI versus domain specific AI. And when Watson came out, it very much gave the impression that you were talking about general purpose AI. That's what was so exciting about it. In this context of Jeopardy, it could behave like a human. It could answer all these very obscure, arcane questions in the form of a question. And it looked like, hey, here's this machine that I can start replacing a human with. I can have it work at Wendy's. I can have it diagnose problems with my car. I can have it diagnose cancer, as was the case, the focus for Watson Health.
hmm yeah, and Watson definitely was sort of a like it seemed like this umbrella brand that IBM was
Yeah,
throwing onto everything that was secretly
absolutely.
AI related, right? So
Even not
um,
AI related. Had a friend who was very familiar with the situation at IBM, and they had like their Watson storage arrays and all this other stuff that was completely unrelated.
That's great. But yeah, yeah, and again, I don't think our intention is to pick on IBM specifically, although I do think they're an interesting case study in real time
Right.
about how, um, hyping up AI too much and I guess setting expectations too high, um, might have consequences down the road. So
Yeah,
yeah,
absolutely. I think we should just read some of the quotes from this article because I
yeah. Let
think
me share it
they're
again real quick here.
very
Go through.
insightful. Yeah,
Yeah, there's quite a few good quotes on here. So
yeah.
yeah, where do you want to start?
Let's see. I'll probably read this one because I think it's really raises the issue. Um, when the notion is, well, we can answer any question in cancer care with this data, it's too overwhelming. We don't have the power to do that right now. That was a quote from David Agus, chief executive of Ellison Institute for Transformative Medicine. And that's absolutely, I mean, I think if you talk to most data science or machine learning practitioners, they tell you exactly the same thing in a much broader context. Like if you try to go to business executives and say, hey, I've got this AI and it's going to tell you what your strategy should be and what your next product should be and how to reinvent your business, that would be totally insane because you would just be bound for failure by doing that.
Yeah, yeah. I remember around the time that IBM had come out with a lot of the Watson, uh, the health product especially.
Right.
There was just I think there was a lot of hype and a lot of expectations that, oh yeah, this is going to be like general purpose and we'll be able to solve figure out cancer. And I think the talk around the time was, yeah, radiologists are going to be obsolete in the next few years. And I mean,
Right.
everyone was setting these like, really aggressive timelines too, and not just like sort of stoked on it and all these expectations, but definitely I think in retrospect being pretty rich with the expectations. So
Yeah. I think part of the problem was that you had this machine that could play Jeopardy, and it appeared to be a general purpose AI. But if you think about it for more than like 30 seconds, you realize that Jeopardy is actually a very, very narrow skill set. And kudos to IBM for solving that problem. Like that was an incredible achievement to come up with a machine that could play Jeopardy and respond correctly and interact with humans in that way. But it's not the same as like training an AI to be a physician or training an AI to recognize every type of cancer or training an AI to run a business. We're very, very far from that, it looks like at this point. Maybe someone will prove us wrong in a couple of years.
Yeah, maybe, and I hope so. I mean, I would think that it's not like these failures, sort of, yeah, they're setbacks, but I think these are just part of the extensive lessons that,
yeah,
not just corporate America needs to go through, but like just the world.
Yeah,
when the claim is that we can have a general AI that can solve medical problems in general. Right now that's probably not the case. Who's to say, right. Decades from now that's not the case. And so, I mean, hopefully this doesn't scare people, but hopefully it like refocuses efforts, into things that might work better. As this article also points out, let me share again here.
Yeah,
kind of more like point solutions, right? Tends to that can solve discrete and narrow problems, right? Like these tend to be, and I think in our experience, where machine learning, at least in this current form, is getting a lot more traction. Is that there's, as this article points out, there's not really it's just really hard to take data and an algorithm for one setting and apply it generally or to another setting. Even it's like, as Andrew Rang points out, the customization problem is severe in healthcare. I would say it's severe in healthcare. It's severe in pretty much every other industry as well, right?
So. Absolutely. Yeah. I mean, one of the key strengths of Watson is it could take all this unstructured text, right? Like it could go read Wikipedia articles and find the answers to Alex Trebek's questions. Okay, fantastic. But the problem is that when you get into the numeric parts and statistical parts of AI, so predicting people's probability of getting cancer, for example, you need to have data very standardized, just like you do in any business setting, for example. You need to know exactly what you mean when you talk about someone's probability of getting diagnosed with cancer. And as Ang is pointing out here, like the standardization of that data is really lacking right now. Different data providers structure their data in very different ways. They talk about the statistics of diagnosis in very different ways. And that's a huge struggle. Even if you could read all that data, you end up comparing apples to oranges when you consolidate it.
Mm-hmm. Yeah, I remember back in the day, working on, like machine learning problems related to fall risk, for example, right? So somebody, you have this care data, and you're going to predict the likelihood of somebody falling, because that, for this particular client, that was a pretty big issue and was an expensive issue, right? And depending how old you are, like you fall and break a hip, your next step's the graveyard, actually. So
it's not good.
It's not good at all, right? You want to figure this out, but it was a really hard problem to solve, I think, at the time. I don't know. Maybe recent techniques would make it better, but the point is, what I also realized too is this was, you have statistics on like falls and accidents. That it's really tricky to surmise that you can have predictive quality from such a data set, right? Because falls, by the very nature, are random. Like this isn't something that you can, I would say, even using like stochastic processes, really like predict like the likelihood of somebody having a fall. It seems a bit dodgy to me. So
yeah,
there's probably some actuarial models I think would at least model like a general population, but to specifically say like this person, at least based on the data set that I had, and I'm sure models with richer data sets might do a better job. But I think just this was, I think, one example of trying to the predictive quality just of the medical data set, which is kind of all over the place, at least the one we had. So again, let's say it isn't totally possible to solve it, but it was hard given what we had. So medical data is just notoriously horrible to work with anyway, right?
Yeah. Well, especially if you have like 10 different insurance companies and each one of them reports data in a different way. Like, for example, what constitutes a fault? Even that is a big question. A lot of insurance companies probably only report it if it results in a broken bone. Others may report any fault that they become aware of in their data set. I think part of the focus now has shifted to better devices, right? So you have the Apple Watch, you have numerous, you have the Fitbit, you have custom data collection devices for patients who are chronically ill. The problem with that, as they bring up in this article, is that patients are getting increasingly nervous about sharing that data with anyone, understandably. It's like, oh, so now you can determine my future based on what my gait is or how much I eat or my level of activity. People are very uncomfortable with that idea, especially given how they've been treated in the past by insurance companies.
Oh yeah, yeah. I think rightfully so as well, right? I mean, I've seen insurance companies giving away, Apple Watches in exchange for, being able to collect data. And I personally, I'll buy my Apple Watch. I don't think I need it subsidized by an insurance company, because again, it's not mandatory, and I just don't know how you're going to use the data. So, no thanks,
Exactly.
right? And the other thing is too, there's a lot of like false positives with this thing. Like at the climbing gym, when I'm bouldering, I'll fall pretty hard, and this thing will go off. And it's like, do you need to call an ambulance like the next 30 seconds? If not, then click the button and quickly. So so I just have this thing off all the time because I'm just constantly taking some pretty big spills. So
yeah.
But I'm
well,
not,
if you're free
also, I don't
soloing,
think I'm at risk of breaking my hip anytime soon, right? So
yeah. Except if you're free soloing, and then you might be.
if I'm free soloing and fall, I think, yeah, I don't think I'm gonna be alive. So
yeah, probably not.
Yeah, don't free solo though. So
that's good. That's reassuring.
Right. So used to, but not anymore. So yeah, but I think this is, again, some of the points from this article is really, it's just ambitious AI is really hard.
Right.
And, kudos to IBM, and I would say also DeepMind and these other companies that are out there, at least taking a swing at things.
Right.
Now, of course, we have to couple this with some pretty aggressive marketing pitches, especially I think that were coming out of IBM.
Yes. Exactly. And I mean, IBM was very effective at kind of taking this notion of general purpose AI. They sold to a lot of banks. They sold into, of course, the bank part is separate from Watson Healthcare, but it's a basic idea where you were able to go into sometimes executives who knew a lot about IT, that is all these huge IT systems, but weren't particularly savvy on the latest technology, and maybe kind of got sold a bill of goods on some of the capabilities of Watson. So they could like bring in this machine that you could talk to and it could supposedly answer questions, and they just didn't see the value coming out of it that they were promised originally.
Yeah, I would say that, IBM's not the only one that, where this happened. I think a lot of AI vendors,
Not at all.
were going out there with general purpose machine learning tools, and some were having good results. I would say the majority of them, it's really hard to do general machine learning.
Absolutely.
Yeah, it's like I said, we'll see what happens in 10 years or whatever timeline. I'm sure there's gonna be a lot of advancements, but hopefully this doesn't set things back either. Like, the thing that kind of irritated me is a lot of these ML vendors that were going out there, knocking on all the doors and making these grandiose promises, is that it set expectations extremely high among C-suites and and other executives. And now I think there's, and rightfully so, some skepticism around, AI and its capabilities. So,
yeah. I think we should call out some specifics here about optimism around these problems. So one paragraph says, other areas where AI has seen some successes include radiology and pathology, disciplines where image recognition software can be applied to answer specific questions, experts said. And I mean, yeah, I've heard, I think we both kind of looked at some of these papers about using image recognition to ask very specific questions in healthcare. And that part of research is very exciting. I mean, the idea that you can give an image recognition software a bunch of data and train it on a particular type of pathology or tumor, and it can answer that one question extremely efficiently, that could have a huge impact on healthcare, because you can look at like one type of cancer, you'll be talking $1 billion maybe of expenses across the world or more.
Mm-hmm. Yeah, but that same algorithm is not going to be able to, like, diagnose other diseases, right? So
Exactly.
I think that's sort of what I think was amiss here. But yeah, I mean, we know people that are working on, AI drug discovery, and it works, right? It's hard, but and even in that space too, it's there's a lot of resources dedicated just to even finding like a drug that will work. So
Right.
again, we're not even closely looped in, but it seems like it's a very hard problem to solve. So
Yeah. But fundamentally, I think the takeaway is that AI at this point it's not a practitioner, right? You don't hire AI to be a physician or to
right,
be a cardiologist or any particular type of practitioner. You use AI as a tool and you figure out where that tool works well. And you also figure out where it doesn't work well and you focus on the problems where it works well and then try to expand that domain of use as much as you can. And then it becomes very exciting because I think in the tool domain, we've seen a lot of progress. In the practitioner domain, not so much at this point.
hmm yeah, I think there's we'll see what happens with stuff like GPT-3 as well, right? I think that was
Mm-hmm.
another kind of barn burner announcement, and people rightfully or unrightfully got very excited about this, and
Right.
kind of made the logical leap to like general AI and so forth. And again, it's if you talk to practitioners, yeah, I mean it's a cool thing. It's it's a big step in the right direction. It doesn't mean you have general AI yet, right? But the interesting thing will be when you can start. What I'm kind of interested in is like all these models are sort of developed in isolation right now. What if there's a way that these models can all talk to each other, and not even sure how that would work, but I mean that's possibly when you start getting something, at least I don't know if it's like AI per se, but at least maybe more ways of combining models together. So
Yeah,
you know,
completely agree.
yeah,
Yeah, I mean, I think in particular, deep learning has shown itself to be very effective. Again, if you define a narrow problem, and a narrow problem can actually be quite large, like recognizing images, it can do a very good job of recognizing images. At this point, what deep neural nets are not doing is like acquiring domain knowledge, even in the short term, let alone the really long term. So, for example, if you have a neural net that's transcribing text, it forgets what was said 2 minutes ago. In fact, it forgets the topic of the conversation. It doesn't even know what the topic of the conversation is. It just kind of knows what the last 45 words are and tries to use those to transcribe. And so that's maybe the next domain, like you're saying. What's the model that stands in for near-term domain knowledge and then long-term domain knowledge that we can combine with these very powerful deep nets that will allow them to start understanding context of decision, context of speech and conversations?
and causality, that would be another interesting one.
Yeah.
So I know that Julia Pearl is working on more kind of causal machine learning and approaches and whatnot. But yeah, I think more than anything, this article to me points out that it's still extremely early days in machine learning and
Yeah.
AI. For as long as these approaches have been around, I mean, we've only really been able to tap into even the slightest bit of potential in the last 10 years. And I would argue, especially in the last, when AlexNet and deep learning really hit the scene, like that's when, we started seeing some pretty tremendous progress. But I mean, that was only a few years ago in the grand scheme of things. Like that, like, I think my youngest son was born at that time, right? So,
Yeah.
like, he's uh, he's still growing. So,
Yes. So is AI. Yeah.
yeah. So I mean, there's still like a ton of potential, and to me, the article was really important because it's like, yeah, it sucks, and it's easy for us to sit back and criticize
Yeah.
IBM and all these other companies for taking a chance. But I think the cool thing is that they did take a chance, and
Right.
um, now again, coupling that with whether or not you needed aggressive marketing in that, I think that's a discussion for another day. But I'm glad there's people out there, paying expensive tuition for the benefit of the broader progress.
Absolutely. Yeah. And I think, I mean, the reality is that when these AI systems came out, each time there's a new big development, it looks like magic, right? And that sometimes we think, oh, it's magic, it can do anything. It's not magic, it's a very powerful tool, and we should focus on how we actually use that tool and then what the next steps will be with that tool. And maybe we will eventually get to general purpose AI. Maybe that happens in the near future. Maybe it's a much longer time horizon. But I think it's a very exciting field to be working in right now. And there are a lot of interesting problems to solve and contributions to make in various domains.
Yeah, I think one thing I want to touch on too is this
Yeah.
quote by Andrew. Let's see, real quick.
Yeah.
Yeah, I mean, this section here, we sort of touched on it earlier, but just the
Yeah,
lack of data collection standards, which,
yeah,
according to the article, which makes taking an algorithm that was developed in one setting and applying it in others difficult.
yeah.
I mean, I think this also sort of hints at just the underlying problem, the reason we started our company and work together is just because the underlying practices of data is just really, really hard, right? So
Yeah.
standardization, quality, all the things that go into making a good model. I mean, I would say in order for you to have like I don't know, maybe like it's a bit of an exaggeration. Generally, I should be able to do anything, right? But I think in order to have smarter, more comprehensive models, that would work across a variety of customers and users, at least with current methods, it kind of presupposes that you have consistent data across all those users and customers as well, right? So
Yeah.
at least a consistent data set that you can feed into a model. Because otherwise, I don't know how it would work. It's just the inputs are different. You can get a different output. It's pretty simple, right? So
And then the problem is that even in the business intelligence world, this is a core problem. So, for example, just standardization of metrics, standardization of data collection across different apps within the company. Even for like a $1 billion company, that becomes a huge problem. So, how do you solve that problem when you're now dealing with thousands, hundreds of thousands of separate organizations that are working together on the problem of healthcare, including clinics and doctors' offices and insurance companies and drug manufacturers? Yeah. So if I feel like if you can focus on this problem, if you create a new startup today, the focus is on the problem of data standardization and detecting differences between data collected across an organization and between organizations, focus on that in the business world, you can probably make a pretty big contribution to the healthcare space as well.
mm-hmm. Yep. Yeah, I mean, it's a problem that we see quite a bit. I mean,
Yeah,
and like we always say, I mean, most companies are barely doing BI, let alone AI. It's
right.
just how it is, right? And it's just because structured data is really hard. When talking, tabular data, it's
Yeah,
notoriously difficult to work with. And then that doesn't even include all your unstructured data, preform text, images, everything else. Combining all that into something coherent, not even talking about AI, but just like getting it into like a coherent space, that's difficult for a lot of companies. But and I think that's also why partners like Snowflake are doing extremely well right now, just because that I think in our mind is the more fundamental problem to tackle right now, which is just getting your data into a form that's usable. So
yeah. Yeah, I mean, it's become very fashionable recently, I think, to talk about the end of structured data. We're going toward NoSQL or just raw text format. But the point is that behind the curtain, what is structured data? Well, if you really look at the fundamentals, it means standardization. And again, raw text data, even if we can process it, is not standardized, and therefore will probably give you not very valuable statistics when you try to run some kind of statistical process on it.
right, makes a lot of sense. Cool. Anything else we want to touch on?
I think that's it for the moment. Go find the article if you can and read it. It is very insightful and interesting, and kind
Yeah,
of draw your own
grab
conclusions.
the title real quick.
Yeah,
Um,
yeah,
yeah, so it's in the Wall Street Journal, and it's called IBM's Retreat from Watson highlights broader AI struggles in health. So
yeah.
you might need a Wall Street Journal subscription to access this. Um, there might still be ways around the Wall Street Journal's paywall.
Or
Um,
find someone with the subscription and see if you can read it that way. Yeah.
yeah, yeah. Don't email me, please.
Right,
Um,
right. No, don't email us.
but yeah, good luck. And yeah, cool. But anyway, we'll have a good week, and we'll see you next week. So,
Sounds good. Yeah, it's nice to have these exciting. Well, I don't know if we call this an exciting development, but there's always interesting news every week. A lot of exciting things to talk about in terms of where
yeah,
the industry is going. So
yeah,
we'll have
exactly.
something else next week.
Yeah. Maybe we'll have to do this more than once a week. So it seems like we're operating at the, more cherry picking articles than anything. So, but
Yeah,
yeah.
that's true. There's a lot we don't talk about.
Mm-hmm. Awesome. Well, cool, Matt. We'll see you next time.
Sounds good.